Okay, it's Mr. Lum again, and today we're going to be talking about how to predict the solubility of salts. So we're going to be looking at if something is going to have low solubility or is going to be soluble. So first we need to define what does low solubility mean. So sometimes we say things like something is insoluble. However, that's kind of a misnomer. Insoluble, everything is a little bit soluble in water, even things like glass. Now, glass doesn't seem soluble at all in water. However, there's a very, very small amount of particles that dissolve in water from glass. Now, and we're going to be looking at that. And so we can't really say low insoluble. We have to call it low solubility. So the definition of low solubility is if anything if a saturated solution of a substance is less than 0.1 molar, 0.1 moles per liter, or in other words, has a relatively low solubility. Now, something that is soluble, well, is something that is greater than has a solubility that is greater than 0.1 molar, or another one that's has a relatively high solubility. So we're given this chart right here of the solubility of common compounds in water, and we have to emphasize that this is at 25 degrees Celsius. So we can read a little bit of this, and what we can see is that all alkali ions are all soluble in water. So anything that is paired with an alkali ion, so Na combined with NaCl is going to be soluble. Na plus anything is going to be soluble. Okay, and same thing with hydrogen ions. If anything's paired up with hydrogen ions, it's going to have a relatively high solubility. So that's pretty much most of your that is all your acids right there. So those are going to be quite soluble. Same with ammonia, and for anions, pretty much anything that is attached to a nitrate is going to be relatively high soluble. So silver nitrate, copper nitrate, those are all going to have relatively high solubilities. Now, here's something here. Now, we have chlorine, bromine, and iodine. Now, with pretty much everything, these things are going to be relatively high solubility, have a high solubility. But if chlorine is paired up with silver or lead or copper 1, it is going to be low solubility, or have a saturated solution that is less than 0.1 molar, or in other words, a saturated solution that is 0.1 moles per liter. Okay, so that's the definition of low solubility and high solubility, or soluble. So let's use this table that we were given and figure out what kind of precipitate forms here. So the question that we're given here is, we're given equal volumes of 0.2 molar solutions of silver nitrate. So again, this is something that is very soluble because we know that nitrate is soluble with everything, and ammonium bromide, and we know that ammonium is soluble with everything. So these are two things that are very, very soluble, and we're going to mix them together and figure out if a precipitate forms. So what we're going to do is we're going to go silver nitrate, and we're going to combine it with ammonium bromide, and that is going to make we're going to have like a double replacement reaction, which is going to be AgBr plus ammonium nitrate. So if we look at this double replacement reaction, we can figure out AgNO3. Well, as we know from here, anything that is combined with NO3 or nitrate is soluble, so this is going to be soluble. And NH4, so anything combined with NH4 is also soluble. This is going to be soluble. And so NH4 and NO3, this is also going to be soluble. Now what we see here, silver and bromine. So here's the bromide ion right here, and way down here is silver, and that, when these two things combine, it's going to have a low solubility. So this is going to be low solubility. Low solubility. Or in other words, this is going to be a precipitate. So we talk about equal volumes of 0.2 molar solutions. The reason why the question says this is because if you mix two equal volumes of 0.2 molar solutions, the resulting solution will be 0.1 molar solutions, and that happens to be our definition of, or on the verge of, something being either soluble or low soluble. And what we see right here is that this is going to be a precipitate that is going to form out. So right here we could write something like aqueous, 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 and right here we would write a solid.